A stranger drifts into the solar system, silent and immense, its arrival unheralded until the faintest of signals reach the great mirrors of our telescopes. It bore no allegiance to the sun, no gentle arc of orbit, no slow and familiar dance that ties planets and comets into predictable paths. Instead, its trajectory carved a line of foreign intent, slicing through our system as though it belonged to another universe. The astronomers who first charted it felt a shiver. Here was something that did not belong, a traveler that had wandered unimaginable distances, untouched by the gravity of our star. They named it 3I, Atlas, the third interstellar object ever known to pass through our celestial neighborhood. It carried with it the weight of mysteries as ancient as creation itself. What strikes first is its silence. Through the void, no signal betrays its origin, no glimmer of activity reveals its inner composition. The void is its language, and distance its cloak. Yet even as the data began to accumulate, whispers of unease echoed through the scientific community. Humanity has long lived with the comfort of believing that the heavens follow rules, that planets spin, that comets loop and return. But this was different. This was the sudden arrival of an interloper, a messenger from a star system we may never see, crossing into our domain uninvited. The opening images of this encounter paint it as both wonder and omen. Imagine a cold stone that has known no sun for millions, perhaps billions of years. A shard of a distant planetary nursery, torn free during the violent birth of alien worlds, it has drifted through interstellar night. Its surface has been sandblasted by cosmic rays, scarred by the emptiness of time. It carries with it stories never spoken, locked in atomic lattices older than our own planet. And now, across the deep black gulf, its path intersects with Earth. The thought alone is staggering. Not a comet drawn by our sun's warmth, not an asteroid from the familiar belts between Mars and Jupiter, but an orphan of another sky, an artifact of elsewhere. In its presence, humanity must confront both its own smallness and its precarious place in the larger cosmos. For if such objects can arrive without warning, if they can traverse the gulfs between stars, then what does this say of the security we imagine around our world? Philosophers might call it destiny, scientists might call it probability, and poets might call it fate. But under all these names lies a single truth. The universe is not still. It sends us visitors. It sends us reminders. And sometimes, those reminders carry with them the possibility of annihilation. The mystery of 3I, Atlas, is not only in its composition, nor in its interstellar origin, but in its potential to alter the very narrative of life on Earth. It is a test of science, of imagination, and of human endurance. A reminder that even across the silence of billions of kilometers, the cosmos has a way of finding us. This is not a comet like the ancients feared, with a fiery tail blazing across their superstitions. It is something stranger, quieter, and infinitely more profound. A fragment of another star's birth, set loose on a trajectory that now brushes the fragile blue marble we call home. And so the story begins with the arrival of a stranger, a cold, silent object from the dark, carrying within it the possibility that, one day, the line of its trajectory may end not in distant space, but here, upon our Earth. The discovery came as so many cosmic revelations do not with thunder, nor with spectacle, but with the faintest traces of light upon a sensor. The Atlas survey, an automated sentinel sweeping the Hawaiian skies each night, was designed not to chase dreams, but to protect. Its purpose was practical, to watch for near-Earth objects, for the small but deadly asteroids that might one day intersect our fragile world. It was this system, cold and methodical, that first caught sight of the wanderer. The detection was almost insignificant, a whisper of motion against the dark canvas of the heavens. Astronomers cross-checked the readings, wondering if it was noise, a trick of the instrumentation, or perhaps an uncharted piece of the endless debris that circles our Sunday. Yet, as the days passed and new data points aligned, a stranger story emerged. Its path was not bound to the sun's gravity in the way every comet and asteroid within the solar system should be. Instead, its velocity was far too great, its arc far too wide. The numbers spoke a truth almost alien. This was an object not born here. Like Oumuamua before it, and the comet Borisov after 3I, Atlas carried the signature of an interstellar traveler. Its eccentricity, the mathematical measure of how stretched an orbit becomes, was greater than one, a mark of exile from any solar cradle. It had not been sculpted by our planets, nor had it danced for eons around our Sunday. It had arrived from the depths between stars, and it would leave again, unless fate drew it otherwise. The realization stirred a strange mixture of emotions. For the scientists at the controls, there was the chance to observe a relic of another system, to study matter forged under unfamiliar suns. For humanity at large, though, there was an unease that could not be softened. Here was proof that the universe is not closed, that the boundaries we draw around our world are permeable. Objects from across the galaxy can, and do, find their way here. The people behind the discovery were themselves caught between wonder and worry. Astronomers, trained to filter out noise and error, suddenly found themselves confronting something that belonged in the realm of imagination. Their instruments had not only looked outward, but had pulled inward the reality of other worlds. The cold lenses of their telescopes had touched, however briefly, the edge of another star's history. In Honolulu and Mauna Loa, where Atlas stations scan the skies, the nightly routine took on a different weight. Each new observation confirmed the trajectory, and with it, the certainty this was not one of ours. It had no anchor here, no cyclical return. The universe, vast and indifferent, had sent us a messenger, and like all messengers from afar, it carried with it the possibility of danger. The history of science is filled with such moments, the quiet discoveries that changed everything. Galileo, raising his crude telescope to the night sky, saw moons circling Jupiter and felt the weight of a new cosmos pressing upon him. Henrietta Leavitt, charting the dim pulses of variable stars, unknowingly unlocked the ladder to measure the universe itself. And now, in the hum of computers and the quiet hum of servers processing light, another revelation was born. The recognition of a traveler, one destined to brush close to our world. It is easy to imagine the silence of the room as the numbers were first shared. To see a few astronomers leaning over a monitor to trace the line of orbit that does not bend like others do. To feel that tingle, that subtle vertigo, when the familiar rules of the solar system give way to something unbound. They did not yet know its size, its mass, its exact composition. They knew only its path, and that alone was enough to send ripples through the scientific community. For the world at large, news of 3I, Atlas, arrived later, diluted through press releases and filtered through headlines. But for those who saw the first data points, the realization was profound. This was not just another asteroid catalogued and forgotten. This was a piece of another world, a fragment cast adrift in interstellar night, now stepping, however briefly, into our stage of existence. It had been noticed, and in that noticing, humanity found itself reminded the universe is alive with movement. The cosmos does not sleep, and sometimes, from across unfathomable distances, the strangers find us. The unbound traveler, that is how astronomers described it, for its trajectory betrayed no loyalty to the Sunday. From the very first calculations, its motion defied the quiet symmetry of our solar system. Planets follow near-perfect ellipses, their paths carved by gravity into predictable dances. Comets loop in long ovals, flaring and fading as they return again and again to the same ancient circuit. But 3I, Atlas was neither planet nor comet of familiar kind. Its path was hyperbolic, a sweeping arc too open to ever close. It came not to circle, but to pass through and then to vanish forever into the depths. This is the essence of an interstellar object. It is not bound by the embrace of our Sunday. Its eccentricity, measured as greater than 1, is a mathematical fingerprint of exile. Oumuamua bore it first in 2017, and Borisov confirmed the pattern in 2019. With 3I, Atlas, the pattern returned, another shard of elsewhere, speeding past us on its own eternal journey. Its speed was staggering. While the average asteroid ambles through the inner solar system at tens of kilometers per second, Atlas rushed in with a velocity that declared its freedom from any solar leash. What does it mean to be unbound? To scientists, it means that this object had wandered for millions, perhaps billions of years, across the thin fabric of interstellar space. It had escaped whatever gravity once held it, the pull of its birth star, the tether of its natal disk, and it had become a drifter between worlds. To philosophers, it speaks of a different kind of loneliness. Imagine a fragment of rock torn from a young planetesimal during the violent birth of another solar system, flung outward into the void. For eons it drifted, lightless, cold, unvisited, until chance drew it toward us. And yet, its very existence within our reach is both miraculous and terrifying. Astronomers once believed such visitors to be almost impossibly rare. The galaxy is vast, the distances between stars immense. That 3 of them have crossed our paths within a handful of years suggests something unsettling. Either the void is more crowded than we ever knew, or our instruments have only now become sensitive enough to glimpse what was always there. This shift unsettles our sense of safety. The solar system, once imagined as a secure island amid the cosmic sea, reveals itself as porous. There is no wall at its edge, no shield to keep out the wanderers. Every so often, a stone from another sun drifts through, indifferent to the worlds it brushes past. And if one day the line of such a traveler should intersect with our own, the consequences would be unimaginable. What makes 3I Atlas different is not only its unbound status, but its potential trajectory. The whispers among astronomers, spoken in hushed tones, wondered at the possibility, could this path, so alien in its origin, one day strike Earth? To be unbound is to be unpredictable. A comet bound to the Sun will return, and its orbit can be mapped for millennia. But an interstellar visitor, it carries with it the uncertainty of the unknown. Small forces, radiation pressure, outgassing, chaotic gravitational nudges can alter its course, and in that uncertainty lies the seed of fear. Consider how such an object appears in the night sky, not as a blazing herald, but as a slow, steady motion against the stars. Night after night, its path is traced, and its hyperbolic escape becomes clear. Yet that clarity does not comfort, it unsettles. For every line drawn on a star chart reminds us, here is a thing that does not belong. Here is a body that owes us nothing, that is passing through as though our sun were a roadside lantern in an infinite dark. Astronomy thrives on the predictable, but interstellar objects are reminders of chaos, of collisions that tear matter from its home and scatter it into eternity. They are born from destruction and carried by chance. And now, one has arrived within the reach of our gaze. The unbound traveler has been named, catalogued, and logged into our charts. Yet naming does not tame it. It remains what it is, an exile from another star, drifting through our system for the briefest of moments, and in that moment forcing us to reckon with the truth that nothing in the universe is ever truly still. The question soon became unavoidable. Was 3I, Atlas, a comet, an asteroid, or something stranger still? From the very first nights of observation, its brightness teased but did not confirm. Astronomers strained their instruments to catch hints of a tail, the gossamer plume of dust and vapor that defines a comet. Some images suggested a faint haze, as though volatile ices were evaporating under the distant touch of sunlight. Others showed only a hard, star-like core, more akin to an asteroid. The debate unfolded like a modern echo of ancient astronomy, when celestial bodies blurred the boundary between myth and science. A comet, by tradition, is a dirty snowball, a fragile relic from the solar system's earliest days. An asteroid, by contrast, is a rockier survivor, denser, less prone to melting into luminous trails. With 3I, Atlas, the evidence did not settle easily into either category. Its interstellar origin added another layer of strangeness. If it were cometary, it carried within it frozen compounds shaped under the chemistry of another star. If it were rocky, it was a fragment of alien crust, a piece of planetary debris hurled outward by catastrophe. At times, it seemed to wear both masks. A faint coma shimmered faintly in some exposures, hinting at sublimating ices. Yet the structure appeared irregular, unstable, unlike the steady plumes of familiar comets. Its nucleus may have been fractured, or hollow, or covered in darkened material that suppressed outgassing. The uncertainty lingered. Was this an ancient comet whose activity was too weak to register strongly? Or was it an asteroid masquerading as one, its surface long since charred into dormancy? The ambiguity unsettled scientists. For the classification of an object dictates the physics of its potential impact. A cometary body, loose and porous, would fragment in the atmosphere, delivering devastation across wide areas. An asteroid, denser and more solid, could reach the surface intact, unleashing destruction on a continental scale. The identity of 3I, Atlas, was not merely academic, it was the key to understanding what its collision might mean for Earth. Historical echoes deepened the debate. Oumuamua had defied categorization, appearing cigar-shaped, tumbling, and lacking any visible coma, yet accelerating slightly, as if propelled by invisible jets of gas. Borisov, on the other hand, had displayed a classic comet's tail, a luminous declaration of its icy nature. 3I, Atlas, seemed to stand between them, a hybrid, as though the cosmos itself were reminding us that its creations rarely fit neatly into human categories. Speculation grew bolder. Some suggested it might be a fragment from the violent disintegration of a larger interstellar body. Others wondered whether it carried exotic ices, compounds that barely exist in our solar system and thus behaved unpredictably under sunlight. A few, wandering into the realm of the speculative, even asked if such an object could be an artifact, though the silence of its signal and the randomness of its path spoke only of natural origins. Still, the mystery remained. Was it comet, asteroid, or phantom, something our classifications had no name for? The answer was hidden in its composition, locked within layers of matter forged in another stellar nursery. And yet, to truly know would require what we did not have: proximity, sampling, a spacecraft dispatched across the gulf. For now, all humanity could do was look from afar, watching as the faint smudge moved against the stars, carrying within it an identity that refused to be named. This ambiguity was itself unsettling. The universe, we believe, should be knowable, its objects categorized, its motions described. But sometimes it resists us. Sometimes it presents us with something that straddles the line between familiar definitions. 3I, Atlas, became such a case, a reminder that our language of comets and asteroids, neat and ordered, may be too small for the vastness of interstellar reality. Before astronomers had time to settle the identity of 3I, Atlas, memory pulled them back to its predecessor, the enigmatic first interstellar visitor that stunned the world in 2017, Oumuamua. Its name, Hawaiian for a messenger from afar arriving first, carried both poetry and dread. It was the warning flare across the night, the revelation that the cosmos could hurl wanderers into our system without ceremony. Oumuamua was small, elongated, tumbling end over end like a shard of cosmic glass, and yet it left a scar in the imagination. Its behavior was unsettling. It showed no bright coma, no obvious tail of vaporizing ices, yet it accelerated in ways no asteroid should. Radiation pressure? Outgassing too faint to see? Or something we did not yet understand? Debates raged in conferences, papers, and late-night discussions. Was it a natural body or something artificial? The most sober voices reminded us that nature, too, creates anomalies, but the seed of doubt had been planted. The universe, through Oumuamua, whispered that it was not obliged to behave according to our expectations. Then came Borisov in 2019, the second interstellar visitor, blazing more traditionally with a cometary tale. Unlike Oumuamua's silent defiance, Borisov appeared familiar, even comforting in its comet-like nature. Yet it too was unbound, streaking into the solar system with the same hyperbolic arc. Its presence confirmed that Oumuamua was not a once-in-a-lifetime curiosity. Interstellar visitors were real, and they were perhaps far more common than we had dared to imagine. By the time 3I, Atlas, arrived, the stage had been set. Humanity was no longer innocent of the possibility. We had been prepared by Oumuamua's strange silence and Borisov's luminous trail. But where those two had passed by without threat, Atlas carried within it a darker potential, a trajectory that aligned, however distantly, with Earth. Suddenly, the thought experiment of an interstellar impact was no longer abstract. It was a scenario that could be drawn on orbital charts, simulated in impact models, and whispered about in worried tones. The legacy of Oumuamua shaped how scientists and the public alike responded to Atlas. The first reaction was not disbelief, for Oumuamua had already taught us that the interstellar could intrude into our system. The reaction was fear. If one object could come close, and another could follow soon after, then perhaps such visits were inevitable, and if inevitable, then collision was not a matter of if, but when. Oumuamua had been a wake-up call. It had forced us to rethink our assumptions about the boundaries of the solar system. It had suggested that the galaxy might be filled with such debris, remnants of planetary formations scattered like seeds across the dark. Borisov had confirmed it, grounding speculation in cometary reality. Together, they had stripped away the illusion of safety. By the time Atlas was detected, the groundwork for dread was already laid. For scientists, the legacy was practical as well as philosophical. Instruments were now tuned more carefully to catch such fleeting objects. Surveys ran their data against models of hyperbolic motion, searching for the eccentricities greater than one that marked interstellar origin. The discovery pipeline was sharpened by experience. Oumuamua had been found almost by luck, Borisov with greater vigilance, Atlas more quickly still. Each visitor refined our readiness. Yet none of this preparation could ease the central tension, the possibility of impact. Oumuamua had passed at a safe distance. Borisov too had been no threat. But what if, one day, the arc of such an object crossed directly with Earth? What if, instead of being a messenger passing by, the interstellar traveler became a weapon of chance, aimed at us not by intention but by the indifferent mechanics of the cosmos? The legacy of Oumuamua was not just scientific, it was existential. It forced us to ask whether we were prepared for the uninvited guests of the galaxy, and whether we could ever be ready for the day when one did not merely pass us by. 3I. Atlas carried that question in its path. It bore the shadow of its predecessors and magnified their lessons. If the first messenger had whispered of possibility, Atlas shouted of inevitability. The first orbital models whispered a story both fascinating and terrifying. The trajectory of 3I, Atlas, was not a distant brush, not a harmless arc that would flash across the solar system and vanish forever into the dark. Instead, calculations revealed a line that, when extended forward, curved toward the very place we stand Earth. At first, it seemed impossible. The heavens are vast, and our planet is a speck, but mathematics is unflinching. The margins of error were wide, yet within them lay scenarios in which the stranger's path intersected our own. Astronomers are careful people. They do not leap to conclusions, nor do they shout of danger where uncertainty reigns. Yet, even in their caution, there was unease. The orbital eccentricity was clear. Atlas was unbound, rushing in from another star system. Its speed was enormous, nearly 60 kilometers per second relative to the Sun, a velocity too high for capture. Such speed meant that if its course did align with Earth, the impact energy would be beyond imagination. The process of calculating its orbit unfolded in long nights of data refinement. Each observation, a faint dot against the background stars, was plotted and fed into algorithms. With every new measurement, the trajectory sharpened. Some projections showed safe passage, the object skimming the solar system and vanishing outward again. Others, those that chilled the hearts of those who ran the models, showed a narrow corridor, a gravitational keyhole through which Earth's future could be altered forever. What makes such predictions so haunting is not certainty, but probability. Astronomers know that orbital solutions evolve. A few pixels worth of uncertainty in the position of an object millions of kilometers away can translate into thousands of kilometers of error in future predictions. Yet when one of those futures ends in Earth itself, the air in observatories grows heavier, the discussions grow quieter. The numbers, after all, cannot be uncalculated. The whisper spread. Impact scenarios had appeared. Not guaranteed, not even likely, but possible. And possibility alone was enough to stir unease, for possibility is the seed of inevitability. If this interstellar traveler could even conceivably intersect with Earth, then one day another surely would. The fact that Atlas was unbound, that it came from outside the family of the Sun, only deepened the disquiet. This was not the familiar threat of an asteroid from the main belt, predictable and cyclical. This was the intrusion of the alien, the uncontrollable. The prospect of Earth lying ahead of its path changed the tone of every conversation. No longer was this a curiosity like Oumuamua, a puzzle for theorists and journalists alike. It was now framed as hazard, as existential risk. For an object that had drifted for untold millions of years between the stars, the chance alignment with our small world seemed at once absurd and inevitable, as though the universe, indifferent and vast, had rolled dice across the fabric of space, and we had drawn the wrong number. Such is the cruel poetry of orbital mechanics. A stone cast outward from a distant star system, wandering across interstellar emptiness for ages beyond comprehension, might at last find its destiny not in silence, but in collision. The whispers of its trajectory were not loud, but they were enough. They told us that the possibility of impact was no longer theoretical. It was mapped in the faint light of a star-crossing stranger, charted in equations and confirmed by observation. And so, astronomers leaned closer to their screens, their charts, their telescopes, watching not just a visitor, but a potential executioner. The cosmos had spoken through numbers, and those numbers whispered of Earth. Probability is a quiet word, yet it carries the weight of fate. When astronomers speak of impact probabilities, they are not conjuring certainties, but they are acknowledging futures that cannot be ignored. With 3I, Atlas, those futures were unsettling. Orbital models revealed corridors of possibility, narrow gravitational pathways that could bend the traveler toward us. Each simulation added nuance. Each observation refined the numbers, but the spectre remained. Earth was no longer excluded from its reach. The shock lay not only in the mathematics, but in the enormity of what such an impact would mean. The kinetic energy of a body of this speed and scale was beyond anything humanity had faced in its history. Tens of thousands of times more powerful than our greatest weapons, enough to rewrite the biosphere in a single day. And unlike the asteroids we monitor from within the solar system, Atlas had arrived almost without warning, plunging into our awareness only months before its close approach. It was the nightmare scenario astronomers had long whispered about. Too little time, too great a speed, too alien a trajectory. To the public, the word possible sounded like inevitable. Whispers escaped the halls of observatories and spread into media headlines. Could an interstellar rock truly be on a collision course with Earth? Some dismissed it as scaremongering. Others clung to denial. But within the scientific community there was a heavy silence. For though the odds were small, they were not zero. And in matters of planetary survival, non-zero is enough to inspire dread. The disbelief was compounded by the violation of expectation. For centuries, we had watched comets and asteroids return in predictable cycles. We mapped their orbits, catalogued their names, reassured ourselves with knowledge. But Atlas was the outsider. It had no history with our sun, no predictable loop. Its path was foreign, and that foreignness magnified the fear. If even one unbound traveler could fall toward us, then the universe itself seemed suddenly more dangerous, more indifferent than we had allowed ourselves to believe. Scientists debated late into the night. How reliable were the early models? Could solar radiation pressure alter its path, as it had with Oumuamua? Was the faint suggestion of outgassing enough to nudge it closer to Earth? Every uncertainty became a shadow in the discussion, a reminder that precision is fragile when measuring something so distant, so faint. Yet, the very act of asking these questions revealed the undercurrent of alarm. For humanity at large, the psychological shock was profound. Our myths have always feared the falling star, the celestial omen. Now, that fear was clothed not in prophecy but in equations. The sky, once a dome of reassurance, revealed itself as a passageway for strangers from other suns, some of which could fall upon us without mercy. The paradigm shifted. It was no longer enough to watch for near-Earth asteroids born of our solar family. The galaxy itself was open, porous, alive with debris that drifted freely between stars. And in that debris lay potential catastrophes, not bound by cycles we could predict, but arriving suddenly from the silence of interstellar night. The scientific shock was not merely the possibility of impact, but the realization that the rules we had relied upon were too narrow. The cosmos had widened its scope of threat, and in widening, it had forced us to see ourselves anew, not as safe within the walls of a solar system, but as exposed, fragile, and temporary in the grand corridors of the Milky Way. If fear began with the trajectory, it deepened with the question of mass. What, truly, was 3I Atlas made of? The faint smudge of light captured by telescopes gave clues, but no certainty. Brightness hinted at size, yet reflectivity clouded the estimate. Was it a dark, carbon-rich body that swallowed sunlight and revealed itself only faintly? Or was it an icy fragment, shimmering faintly against the void? The answers mattered, for mass dictates devastation. Calculations unfolded in observatories and research centers. If the object were only a few hundred meters across, its impact would still exceed the force that ended the reign of the dinosaurs. If it were larger kilometers in scale, then the energy released would be enough to sterilize continents, plunge the Earth into decades of climate collapse, perhaps even erase civilization itself. The uncertainty was unbearable, for the same faint glimmer could conceal a pebble compared to worlds, or a mountain compared to cities. Telescopic spectra offered whispers of truth. Some wavelengths suggested the presence of volatile compounds, as if ices lay beneath its surface. Others reflected more stony signatures, silicates that spoke of a rocky crust. The data oscillated between identities, comet, and asteroid, as though the object itself mocked our attempts to categorize it. And beneath all of it lingered the most unsettling possibility, that the body was fractured, hollow, or composed of material never before encountered. For what is interstellar rock but a relic of alien chemistry, shaped by a star whose light we will never see? Mass is not only a measure of weight, but of time. A heavier object travels through the atmosphere differently than a fragile one. A comet-like shell might fragment high above Earth, raining destruction across wide swaths of land and sea. A dense asteroid might plunge intact to the surface, striking with a singular blow of catastrophic force. Without knowing the true mass and structure of 3I, Atlas, predictions of its fate upon contact with Earth remained haunted by uncertainty. And yet, the very ambiguity was instructive. It reminded humanity that the cosmos is not an ordered catalogue, but a storm of possibilities. Every rock drifting between the stars carries its own history. Fragments of planetary collisions, shards from failed worlds, frozen relics of protoplanetary disks. Atlas could be any of these. It could be a time capsule from the dawn of another system, or the survivor of an apocalypse far away. Its mass was not just a number, but a narrative one that carried within it the power to end ours. In the stillness of the night, astronomers stared at the figures and saw both promise and doom. To measure the mass of 3I, Atlas, was to glimpse into a future we could not choose. Was this an emissary of knowledge, a chance to study alien matter, or was it a harbinger of annihilation, an uninvited weapon hurled by chance across interstellar distances? The mystery of its interior compounded the unease. Beneath its scarred surface could lie caverns of frozen gases, ready to explode as it neared the Sunday. Or perhaps a dense iron core, unyielding, forged in the depths of an alien protoplanet. Each possibility carried different consequences, each one equally beyond our control. The uncertainty itself was a kind of terror, and so mass and mystery became entwined. Every calculation, every spectrum, every image was an attempt not just to know the traveler, but to predict our own survival. For in the collision of worlds, the weight of a stone is the measure of eternity. Time itself became the next revelation. To trace the path of 3I, Atlas was to gaze not merely across space, but across unimaginable epochs. For this was no local wanderer, no child of our Sunday. Its orbit bore the unmistakable mark of exile. It had been cast adrift from another star system long before the first humans stood upon the Earth. Perhaps before Earth itself had cooled enough to bear oceans. Interstellar objects are not young. They are ancient debris from the earliest ages of planetary birth. Astronomers imagine a scene, a newborn star, still swaddled in a disk of gas and dust. Within that disk, matter collides, fuses, and fractures. Planetesimals take shape, embryonic worlds forming amidst chaos. Some are swallowed by gravity, bound into orbits that will last for billions of years. Others are doomed to exile, nudged by collisions or the tugs of giant planets until they are hurled beyond escape velocity. One such exile, flung outward in violent youth, could become an interstellar traveler, and if its path intersects with another system ages later, it becomes what we now call 3I, Atlas. The age implied is staggering. Atlas may have drifted through interstellar space for hundreds of millions, perhaps billions, of years. Its surface would have been darkened and scarred by cosmic rays, its volatile compounds slowly eroded by the faint but relentless radiation of the galaxy. Unlike comets that slumber at the edges of our own solar system, awaiting a chance to fall inward, Atlas has known no home, no return. Its journey has been one of endless night. To measure such timescales is to confront human fragility. Civilizations rise and fall in mere thousands of years. Species bloom and vanish in millions. But Atlas has endured far longer. It may have left its cradle when the first multicellular life was just beginning on Earth, or when dinosaurs walked, or long before. It is a messenger not only from another place but from another age. For astronomers, this deep time complicates every question. If Atlas is a relic of another system, then its chemistry may reveal conditions unlike any we know. Perhaps it carries isotopes formed under alien nucleosynthesis, fingerprints of stars long since extinguished. Perhaps its mineral structure tells of planetary processes foreign to Earth. It is not only a potential threat, but a library of cosmic history. To destroy Earth, it need not speak its mere existence already, whispers of timelines far beyond our own. Philosophers find in this an even heavier weight. To imagine Atlas is to imagine solitude, a fragment wandering the dark for eons, indifferent to the absence of witness. If life exists elsewhere, it may be as fleeting as ours, but the stones, the dust, the debris endure. They are the fossils of worlds, traveling endlessly between suns. They outlast the stars that birthed them. They outlast civilizations, species, and dreams. The timescales also magnify the horror of chance. For billions of years, Atlas drifted harmlessly. It crossed gulfs between stars without contact. And yet, in this brief moment, in the thin slice of time when humanity looks upward with telescopes, its path bends near Earth. The odds are infinitesimal, yet the cosmos had billions of years to roll its dice, and now the dice show our number. Such is the nature of interstellar visitors. They remind us that time is not a shield. The fact that Earth has survived thus far is no guarantee. Every moment of safety is purchased by chance, and chance is patient. The universe waits. And sometimes, after billions of years of silence, a traveler arrives to remind us of the precariousness of our place in time. The physics of collision is a language of violence written in equations. If 3I, Atlas, a body unbound and rushing at interstellar speed, were to meet Earth, the energy unleashed would be beyond the measure of human history. To imagine it is to stand on the edge of comprehension, staring into scales of power that dwarf volcanoes, earthquakes, even the combined arsenal of every weapon ever made. The key lies in velocity. An asteroid from within our solar system might strike Earth at speeds of 20 kilometers per second, 3I. Atlas, by contrast, hurtles through space at nearly 3 times that. At such speeds, even modest mass becomes apocalyptic. The equation is simple, yet merciless. Kinetic energy scales with the square of velocity. Double the speed, quadruple the energy. At 60 kilometers per second, Atlas carries a magnitude of destruction beyond anything humanity has ever calculated for an inbound body. What would such a collision mean? First, the conversion of motion into heat, an instantaneous transformation of cosmic velocity into fire. Upon contact with the atmosphere, compression would ignite the air ahead of it, generating a blinding flare brighter than the sunday. The surface of the object itself would vaporize in an instant, peeling away in incandescent sheets. If it were dense enough to reach the ground intact, the impact would release energy equivalent to millions of nuclear bombs. Shockwaves would ripple outward from the point of collision, shattering bedrock, igniting forests, and boiling seas. If the strike were oceanic, walls of water would rise higher than cities, racing toward coasts with annihilating force. If it were continental, mountains would crumble, plains would ignite, and skies would be filled with molten ejecta hurled halfway to space. The impact crater could measure tens or hundreds of kilometers across, a wound in the crust that would last for millions of years. The comparison to past catastrophes offers only partial guidance. The Chicxulub impactor, which ended the reign of the dinosaurs 66 million years ago, was perhaps 10 kilometers wide, traveling at typical asteroid speed. Its collision devastated the biosphere and extinguished 3/4 of all species. Atlas, depending on its true size and density, could carry far greater kinetic fury. Its interstellar velocity makes even smaller dimensions devastating. A mere half-kilometer body, if intact, could rival Chicxulub in energy released. A multi-kilometer mass would surpass it many times over. But beyond the immediate fire and shock lies the slower, subtler catastrophe, the veil of dust. Material blasted skyward would circle the globe, shrouding sunlight for years. Photosynthesis would falter, food chains would collapse, and the climate would plummet into an artificial winter. The violence of the first day would be only the beginning. The extinction that followed would be written in famine, cold, and silence. Physics speaks without emotion, yet its implications resonate with dread. For all the equations of momentum and energy, the human mind struggles to grasp scales so immense. We are creatures of hearth fires and cities, of storms and earthquakes. But an interstellar collision is a phenomenon that transcends imagination. It is not merely natural disaster, but planetary catastrophe. And still, the physics holds no malice. It is indifferent. A stone, cast outward from an alien system long ago, drifts across time and space until the line of its path crosses ours. There is no intention, no design, only mechanics. Yet in that mechanics lies the possibility of erasure. To speak of the physics of collision is to confront not only the numbers, but the silence behind them. For in the end, energy has no care for what it destroys. It burns, it shatters, it alters climate and ocean and sky. And if 3I, Atlas, were to strike Earth, the physics would not pause for prayer or protest. It would unfold as it always has, as it always will, with the cold inevitability of nature. The fragility of a planet is revealed in its scars. Earth bears them silently, etched into continents and sea floors, reminders of a past shaped by collisions. To study the possibility of 3I, Atlas striking our world is not to imagine an unprecedented event, but to recall that it has happened before. The craters of Earth are the chronicles of ancient violence, each one a testament to how delicate life's hold can be. Consider the vast wound in the Yucatan Peninsula, the Chicxulub crater. 66 million years ago, a body perhaps 10 kilometers across plunged into the shallow seas there, releasing energy beyond comprehension. The dinosaurs, rulers of the Earth for over 150 million years, were swept away in a geological instant. 3/4 of all species vanished, and yet from that destruction came the conditions for mammals and eventually humans to rise. Extinction and creation, intertwined by catastrophe. Chicxulub was not alone. In Arizona lies Meteor Crater, a mile-wide scar carved 50,000 years ago by a relatively small iron fragment. In Siberia, the Tunguska event of 1908 flattened 2,000 square kilometers of forest. Though no crater was left, the body exploded in the air, scattering devastation across the taiga. Each of these was a whisper compared to what an interstellar impact might unleash, yet all remind us of Earth's vulnerability. The Moon, airless and unprotected, offers an even starker vision. Its surface is pocked with craters of all sizes, preserved for billions of years. It is a graveyard of impacts, a mirror of what Earth itself endured before wind and water softened the evidence. The Moon's battered face reveals what our atmosphere and oceans conceal, that bombardment is not rare, but inevitable, in a universe filled with drifting bodies. 3. Atlas enters this lineage not as an abstract threat, but as a continuation of history. The scars beneath our feet tell us plainly, impacts shape worlds. They reset ecosystems, alter climates, and even redirect the path of evolution. Humanity itself exists in part because of a collision that cleared the Earth of its former rulers. But that truth brings little comfort. For if life was once extinguished, it can be extinguished again. The fragility of Earth lies not in its rock and ocean, but in the thin veil of life upon it. A biosphere that stretches only a few kilometers above and below the surface, delicate as mist upon a stone. Within that veil, every tree, every animal, every human being depends on the stability of climate, atmosphere, and food chain. An impact from a body like Atlas could shred that stability in a single moment. And so, the old craters become warnings. They whisper across time that survival is never guaranteed. Civilization, for all its towers and machines, is no stronger against cosmic fire than the forests of Tunguska or the reptiles of Cretaceous seas. The planet is durable, life is not. To look at 3i, Atlas is to see not just an object in the sky, but a reflection of the scars already written into Earth's crust. It is to remember that our world is not invincible, but fragile, temporary, and shaped by chance. The next great scar may not be millions of years in the making. It may arrive in our own. Imagine the sky itself becoming a furnace. Long before 3i, Atlas ever reached the ground, its arrival would ignite the heavens. At 60 kilometers per second, the atmosphere would not cushion its fall, but weaponize it. Air, compressed ahead of the plunging body, would heat to tens of thousands of degrees, hotter than the surface of the Sunday. The object would blaze across the firmament as a second star, outshining daylight, turning night into fire. The spectacle would be terrifying and magnificent. Across continents, people would look upward and see a trail of incandescent plasma tearing the sky apart. Shockwaves would roll outward, rattling windows thousands of kilometers away. For an object of interstellar mass and speed, this was not a meteor, it was an apocalypse clothed in light. If the body were fragile, it might fragment high above the Earth. Yet even then, destruction would cascade. Each fragment would blaze with its own fireball, scattering devastation across a region the size of nations. If denser, if iron or stone at its heart, it would endure, plunging deeper, carrying its fury toward the surface. And with every kilometer descended, the fire would grow, a torch that spread heat and destruction below. Forests would ignite spontaneously beneath the blazing path. Grasslands would catch fire as if struck by lightning from above. Animals and people alike would see the horizon consumed not by flame rising from the ground, but by fire falling from the heavens. The atmosphere itself would become a weapon, feeding the descent with oxygen and heat until Earth below was a theater of burning. Such visions are not speculation alone. The Tunguska event showed the ferocity of atmospheric explosions, flattening 2,000 square kilometers of forest with a body no larger than a modest asteroid. Yet Atlas would be greater, faster, heavier, forged under alien suns. Its entry would not merely level forests, it would set entire continents aflame. Scientists model such entries with supercomputers, tracing shock fronts, fragmentation patterns, and radiant heat. The results are consistent. An interstellar strike would dwarf anything humanity has ever recorded. The sky would split in light and thunder, shock waves circling the globe, reverberating in the bones of the planet itself. And then silence. After the blazing descent, after the skies had burned, the world would change. Whether the object fragmented in the air or struck the surface whole, the fire in the sky would mark only the beginning. The true devastation would come in waves of shock, dust, and climate collapse. Yet the first image would remain forever, a horizon consumed in flame, the heavens themselves appearing to fall. This is the terror of atmospheric entry, that the sky, which shelters us, can become the instrument of destruction. For in the descent of 3I, Atlas, the blue dome above would cease to be a roof of safety and become instead the stage of apocalypse. And the memory of that vision, were any to survive it, would outlast all words. After the fire in the sky comes the violence of the Earth itself. An impact of 3I, Atlas, upon the planet's surface would not end with blinding light and searing heat. It would continue in waves of force that ripple through land and sea alike, a global convulsion written in shock waves. The first wave would be seismic. The ground beneath the impact site would shatter instantly, releasing energy equivalent to millions of earthquakes at once. Bedrock would ripple like water, fault lines trembling as though the entire lithosphere had been struck with a cosmic hammer. Across continents, tremors would rattle cities, collapsing buildings and splitting highways. The Earth's crust, normally slow to shift, would move violently, a reminder that tectonic stability is fragile against the scale of interstellar impact. From the point of collision, a shock wave would roar outward at supersonic speed. Winds stronger than any hurricane would flatten forests, strip landscapes bare, and hurl debris with lethal force. The shock front, a wall of compressed air, would carry enough energy to demolish everything in its path. Those not burned in the atmospheric entry would be shattered by its concussion, their surroundings torn apart in an instant. If the object struck the ocean, the consequences would be no less catastrophic. The impact would displace billions of tons of water, sending tsunamis racing outward across every shore. Waves hundreds of meters high would slam into coastlines, erasing ports, cities, and entire nations within hours. Unlike earthquakes, which give coastal regions precious minutes of warning, an interstellar strike would provide almost none. The ocean itself would become a weapon, its fury magnified by the scale of the event. And then there is the global fallout. Material vaporized at the point of impact would be hurled into the atmosphere, raining molten rock across thousands of kilometers. Forests already burning from atmospheric heating would be pelted with fire. Fields, rivers, cities, all caught beneath a storm of falling stone. What escaped Earth's gravity would circle the globe as ejecta, a shroud of dust and ash that would soon darken the skies. Historical parallels offer only pale glimpses. The Chicxulub impact raised tsunamis across the ancient seas, sent shockwaves that circled the Earth, and spread molten rock as far as modern-day North America. The Tunguska event, though far smaller, flattened trees across an area larger than some countries. 3I, Atlas, moving faster, heavier, and alien in composition, would unleash consequences magnified many times over. The cascading effects would be terrifying in their totality. Earthquakes triggering landslides, volcanoes destabilized by sudden shocks, ocean waters churning with violent tides. For days, perhaps weeks, the planet itself would tremble as if wounded, its systems groaning under the force of the collision. Civilization, fragile and interconnected, would fracture instantly. Power grids, communication networks, transport systems, all erased within the radius of devastation. The survivors beyond would inherit not merely chaos, but a transformed Earth. And yet, the strangest part of imagining such an event lies in its inevitability of sequence. First fire, then shock, then ocean, then sky. Nature does not pause between acts. It unfolds destruction as though it were choreography, written not for malice, but for inevitability. 3I, Atlas, if it struck, would write its story not only in the heavens, but in the ground beneath us. It would remind us that the Earth itself is fragile, not an unshakable foundation, but a surface vulnerable to forces from beyond the stars. The shock waves across continents would be the echo of the universe itself, reminding humanity that no wall, no nation, no civilization can shield against the indifference of cosmic mechanics. The world after such an impact would not only be shaken, it would be transformed into a different planet. The immediate devastation of shock and fire would pale before the slower, suffocating catastrophe that followed, for the atmosphere itself would change, carrying in its veil the seeds of a shattered climate. When 3I, Atlas struck, billions of tons of pulverized rock and vaporized material would surge skyward, lifted high above the stratosphere. There, beyond the reach of cleansing rain, the fine dust would spread in a global shroud. Sunlight, once steady and warm, would dim. Days would fall into twilight, and twilight into cold. Crops that depend on the rhythm of the sun would wither, forests would weaken, and the balance of ecosystems would unravel. Scientists call it an impact winter, a term borrowed from the chilling language of nuclear war. The principle is the same: block the sun, collapse the climate. Within weeks, average global temperatures could plummet by double digits. Oceans would cool at their surfaces, altering currents and weather systems. Rainfall patterns would break, leaving some regions in endless drought while others drowned in relentless storms. The biosphere, delicate as silk, would falter. Photosynthesis would collapse as light waned. Plants would die, and with them the animals that feed upon them. Hunger would ripple upward through every chain of life. Humans, reliant on harvests and herds, would face famine on a scale unseen in recorded history. No stockpile of grain, no vault of seeds, no modern infrastructure could soften the blow of a global winter lasting years. And still, there would be other poisons. If 3I, Atlas struck continental crust, sulfur compounds could be lofted into the atmosphere, forming aerosols that further darkened the skies and seeded acid rains. If it plunged into an ocean basin, chlorine and bromine compounds might strip ozone from the stratosphere, exposing survivors to lethal ultraviolet radiation once the skies cleared. The planet would not only grow colder, but stranger, more hostile to the fragile forms of life that once thrived under its sunlit skies. The parallels are haunting. Chicxulub's winter is believed to have lasted years, perhaps decades, reshaping the climate until the dinosaurs could no longer endure. In Siberia, massive volcanic eruptions 250 million years ago spewed gases that collapsed ecosystems and drove the greatest extinction in history. These events remind us that life, though resilient, is not invincible. It bends under the weight of global catastrophe, and sometimes it breaks. For humans, whose civilization is tuned to narrow bands of climate, the danger is magnified. Cities by the sea would vanish beneath tsunamis, but those inland would not be spared. Supply chains would crumble, governments collapse, and societies fracture under the weight of starvation. Wars might erupt over dwindling resources, compounding the suffering inflicted by the cosmos. Survivors would find themselves in a world where the stars still shone, but the sun itself had been muted, turned into a pale disk above a planet clothed in ash. It is here, in the image of a frozen earth, that the terror of 3I, Atlas, deepens. Not only could it burn us in its arrival, not only could it shatter continents and oceans, but it could also smother the very climate that sustains life. Fire followed by ice, heat followed by silence. The planet, once vibrant, would fall into a coma of cold. The shattered climate is the lasting legacy of such an impact. Long after the flames have died and the shock waves ceased, the dust would linger, the cold would endure, and the silence of barren fields would echo louder than the thunder of the strike itself. For it is not the explosion that ends civilizations, but the absence of sunlight the slow starvation of the world beneath a darkened sky. The legacy of such a catastrophe would not only be geological or climatic, it would be biological, etched into the story of life itself. For an interstellar impact of 3I, Atlas's magnitude would ignite an extinction echo, a repetition of the cycles that have reshaped Earth again and again. History is already scarred with these echoes. The Permian extinction, 250 million years ago, erased more than 90% of marine species and 70% of life on land, leaving the Earth desolate before new forms emerged. The Cretaceous extinction, carved by the Chicxulub impact, silenced the thunder of dinosaurs and cleared the way for mammals to inherit the Earth. Each event was both an ending and a beginning, a reminder that the survival of species is never guaranteed. If Atlas struck Earth, its echo would be no less profound. The collapse of climate would trigger cascading losses across ecosystems. Species already fragile under human pressure, the great predators, the delicate amphibians, the complex webs of coral reef life would vanish first. The more resilient might endure for a time, but as food chains snapped, even they would falter. The forests would thin, the oceans grow barren, the skies fall silent of birds. It would be as though the biosphere itself inhaled for the last time. Humanity, though clever and resourceful, is no exception. Our resilience lies in technology, in the ability to adapt, store, and plan. Yet technology cannot make crops grow without sunlight, nor can it conjure clean air from sulphurous skies. Civilizations, finely tuned to balance and abundance, would collapse under the weight of scarcity. The extinction echo would resound not only in the loss of animals and plants, but in the silence of cities, the crumbling of towers, the disappearance of languages and cultures. And yet, paradoxically, extinction echoes are also engines of renewal. After Chicxulub, mammals emerged from the shadows, their smallness once a liability, now an advantage in a shattered world. From ruin, diversity eventually returns, branching into new forms shaped by new pressures. If humans were to vanish, another lineage might one day rise, inheriting a planet reshaped by catastrophe. If we survived in remnants, our species would be transformed by struggle, our civilization rewritten in the harsh ink of scarcity. The extinction echo of 3I, Atlas, would not be kind, but it would be final in its authority. Life that had flourished for millions of years would end in moments. Those that endured would carry the marks of survival, their genomes rewritten by chance, their histories reset. The world that emerged centuries later would be alien to the one we know today. This is the paradox at the heart of impacts. They destroy, but they also create. They silence, but they also reset. Without Chicxulub, there would be no us. Without the Permian catastrophe, the lineage of dinosaurs might never have risen. Catastrophe is both predator and midwife, both executioner and creator. And so, to imagine 3I, Atlas colliding with Earth, is to imagine not only the death of civilizations and species, but the birth of futures beyond us. Extinction echoes are cruel, but they are also cosmic reminders that nothing is permanent, not dominance, not fragility, not even survival. They are the universe's way of writing in cycles, and humanity is only one stanza in the long poem of life. Albert Einstein once warned that the universe was not only stranger than we imagine, but stranger than we can imagine. His own work revealed a cosmos where space and time are not fixed, where gravity is the warping of reality itself. To speak of 3I, Atlas, in Einstein's light, is to recognize that collisions on a cosmic scale are not accidents but inevitabilities written into the fabric of space-time. General relativity teaches us that every mass curves the geometry of the universe. Planets, stars, galaxies, even a wandering stone from another star system bend the invisible grid of space through which they move. The trajectory of Atlas is no mere line across a star chart, but a path etched in curved space-time, a geodesic laid down long before we noticed it. Its meeting with Earth, should it occur, is not fate in the mystical sense, but destiny in the mathematical one. It is the unavoidable consequence of two masses inhabiting the same web of geometry at the same moment. Einstein's equations allow no favoritism. They do not privilege life, civilization, or even planets. They describe a cosmos where objects follow their curves until they meet, and when they meet, energy is released. The same mathematics that explains the orbit of Mercury or the bending of starlight also explains the violence of an impact. The elegance of relativity contains, folded within its symbols, the seeds of annihilation. There is something terrifying in this impartiality. Human beings crave meaning, but physics offers none. Relativity does not promise safety, only prediction. If Atlas were to strike Earth, it would not be because of intent or punishment, but because the geometry of space and time decreed their paths would cross. The cosmos, through Einstein's lens, becomes at once beautiful and merciless. And yet, relativity also gives us the tools to see further. It allows us to chart the heavens, to map the orbits of distant wanderers, to predict whether a path will graze us or destroy us. It is the mathematics of both dread and hope. Einstein's warning is not only of inevitability, but of understanding. In grasping the fabric of space-time, humanity gained the power to foresee. Whether we have the power to act is another matter. In reflecting on Atlas, one feels the echo of Einstein's broader concerns. He feared the fragility of civilization in the face of forces greater than ourselves: war, ignorance, destruction. Yet the cosmos itself, he knew, was the greatest of all forces, indifferent and vast. The collision of worlds is simply another expression of the same universe that bends light and guides planets. To live in such a cosmos is to live under laws that care nothing for us. And so, Einstein's warning lingers, not in prophecy, but in principle. The inevitability of collisions is written into relativity itself. Space-time is not a shield. It is the stage upon which matter moves, and sometimes, disastrously, collides. Atlas is not an intruder in this sense, but a participant in the same dance. It is we who have grown accustomed to imagining safety and relativity that strips that illusion away. If Atlas reminds us of anything, it is that Einstein's universe is not gentle. It is precise, astonishing, and vast, but within its elegance lies the cold truth that annihilation and creation are equally natural. The laws that allow life also allow its end. To see Atlas through Einstein's eyes is to understand both the inevitability and the indifference of cosmic collisions. Stephen Hawking spent his life gazing into abysses, black holes, singularities, the very edges of time. His voice, quiet yet profound, carried warnings as well as wonder. He often reminded us that civilization walks on fragile ground, that one great disaster could erase the work of centuries. In the shadow of 3I, Atlas, Hawking's words echo with renewed urgency. Hawking understood that the cosmos is both cradle and executioner. His studies of black holes revealed that even the most massive and eternal-seeming structures are not safe from decay. If black holes themselves evaporate across time, how much more fragile is a world of forests, oceans, and delicate human societies? When he spoke of existential risks, he did not do so idly. He knew that intelligence alone is no shield against physics. To imagine 3I, Atlas colliding with Earth, is to stand in the very shadow Hawking described. An unbound traveler from another star, indifferent to life, approaching with annihilating speed, this is the embodiment of the risks he feared. It is not malice that would destroy us, but chance. A fragment of ancient debris, set free billions of years ago, could end the entire human story in a single day. Hawking often warned that humanity must look to the stars, not out of curiosity alone, but out of necessity. He spoke of building colonies on the Moon, on Mars, on artificial habitats, lifeboats against cosmic catastrophe. He knew that on a long enough timeline, Earth cannot be safe. Whether by asteroid, supernova, or our own recklessness, the fragility of our species is inescapable. 3i Atlas, as a case study, illustrates his argument in the starkest possible way. If survival depends on a single planet, survival cannot be assured. And yet, there is a paradox. The very knowledge of such threats comes from the same scientific spirit that Hawking championed. We know of Atlas because of telescopes, algorithms, surveys, the patient work of minds seeking truth. We can model its orbit, predict its trajectory, and even imagine defenses. This is our strength, awareness. But awareness is not immunity. Hawking's shadow falls because the universe does not bend to knowledge alone. To survive requires action, preparation, and a humility before forces larger than ourselves. If Atlas were to strike, it would be the fulfillment of Hawking's warning, not because he predicted this object, but because he foresaw the pattern, that fragile civilizations fall not only to war or disease, but to indifference written in the stars. The collision of a body from another system would be proof that our fears are not fantasies, but inevitabilities on cosmic timescales. Yet Hawking also carried a quiet optimism. He believed that the human spirit could endure, that intellect and imagination might carve a path even through catastrophe. He once said that we are just an advanced breed of primates on a minor planet of a very average star, but we can understand the universe, and that understanding, fragile as it is, may be our salvation. In the contemplation of 3i Atlas, Hawking's shadow reminds us of both peril and possibility. The peril, that existence is fleeting, always under threat from the indifferent cosmos. The possibility, that knowing this, we may yet prepare, spread outward, and endure. Whether we do or not depends on how seriously we take the warning. For the universe offers no mercy, only opportunities for foresight. The recognition of danger naturally gave rise to a single question. Could humanity defend itself against an interstellar strike? The answers, when whispered in laboratories and space agencies, were sobering. For though we have imagined methods of planetary defense, none were designed with an object like 3i Atlas in mind. The first concept is the gravity tractor, a spacecraft placed near an asteroid, hovering long enough to pull its path subtly off course. Over years or decades, the delicate tug of gravity could shift the orbit of a hazardous body just enough to miss Earth. But Atlas was different. Its velocity was immense, its trajectory steep, and its warning time far too short. Gravity tractors, beautiful in theory, are powerless when the visitor is rushing at tens of kilometers per second from interstellar space. The second idea is nuclear deflection. Humanity, grimly familiar with the destructive power of fission and fusion, has imagined turning such weapons outward, detonating near an asteroid to vaporize its surface and nudge it away. In simulations, such explosions can alter paths if done years in advance. But Atlas, coming so suddenly, allows no such luxury. And worse, its composition is unknown. A fragile, icy body might fragment under such force, raining multiple smaller impacts upon Earth. A dense, iron core might scarcely shift at all. The risk of making catastrophe worse shadows every nuclear proposal. Other methods, kinetic impactors, solar sails, focused lasers, all share the same flaw. They require time, decades of preparation, early detection, and careful planning. Interstellar objects deny us that. They emerge into our system with little warning, racing across space before instruments even register their arrival. By the time their trajectories are understood, the window for intervention has already closed. And so, the defenses we imagine appear almost like illusions, comforting but frail against the reality of cosmic speed. The unsettling truth is that if Atlas were truly on course for Earth, we would be powerless to stop it. Our ingenuity could model its descent, map its destruction, even broadcast warnings. But the blow itself would land unchecked, as unstoppable as sunrise. This is perhaps the harshest revelation of planetary defense, that it is not universal. We are learning to shield ourselves, slowly, from local asteroids and comets. We map the skies, build simulations, and test our tools. But against the unbound wanderers, the true exiles of the galaxy, we stand exposed. The cosmos can still send stones against which no wall can be built. Yet, even in this vulnerability, there is purpose. To imagine defense is to acknowledge the value of foresight. The same systems that detect Atlas also watch the countless nearer bodies that circle our Sunday. Our weakness against interstellar threats does not erase our growing strength against the local ones. To prepare, however imperfectly, is to honor survival itself. Still, the question remains: what can we do, faced with the unstoppable? Some say the only defense is dispersal to carry humanity beyond Earth, to settle new worlds where one collision cannot end us all. Others speak of humility, of recognizing that not every threat can be met with triumph. Perhaps survival lies as much in acceptance as in resistance. In the shadow of Atlas, all strategies feel fragile. The gravity tractor is too gentle, the nuclear strike too crude, the kinetic impactor too slow. We are left with a truth as old as the stars: that some forces are beyond our power. The universe does not ask for our consent. It moves, and sometimes it moves through us. If weapons and deflection seemed powerless against an interstellar strike, one tool still offered a fragile kind of hope: the telescope. For it is in the act of seeing that survival begins. The earlier humanity can spot a wanderer, the greater the chance, however small, of preparing for its arrival. Atlas itself was discovered by a survey telescope designed to scan for near-Earth objects. Night after night, automated cameras swept the sky, capturing faint points of light against the starry backdrop. Algorithms searched for motion, for anomalies, for the telltale shift that marked an object closer than the fixed stars behind it. It was in such routine vigilance that 3I, Atlas, first revealed itself. A tiny smear of photons, translated into data, became the whisper of a cosmic visitor. But even as this achievement was celebrated, its limitations were clear. Atlas had been noticed only when it was already within the solar system, already speeding along a trajectory impossible to alter. If it had been aimed directly at Earth, detection would have given us months, perhaps less, to comprehend the inevitable. Telescopes may serve as our shields, but they are shields of knowledge, not prevention. And yet, knowledge is power of another kind. By mapping the skies with increasing precision, surveys build catalogues of the countless smaller bodies that orbit near our world. Pan stars in Hawaii, Catalina in Arizona, the upcoming Vera C. Rubin Observatory in Chile, each is a sentinel, extending humanity's reach further into the night. Satellites like NEOWISE turn infrared eyes toward the void, detecting heat signatures invisible to optical sensors. Together, they weave a fragile net of awareness, stretched across a sky still vast with unknowns. The dream is early warning, to find dangerous objects decades before they pose a threat, to allow time for deflection or evacuation. With local asteroids, this dream is possible. With interstellar visitors, it remains elusive. Their speeds are too great, their arrivals too sudden. But every discovery sharpens our instruments. Every faint smear of light teaches us to see more clearly. Atlas may not be deflected, but its very detection proves that vigilance works. In truth, telescopes are not shields but mirrors. They reflect to us the reality of our vulnerability. They remind us that the universe is not empty but alive with motion, filled with wanderers unseen until they arrive. They whisper of humility, that the skies we take for granted may at any moment deliver an exile from another star. Still, there is comfort in vigilance. To watch is to refuse ignorance. To measure is to reclaim, in part, a sense of control. We cannot stop every stone, but we can choose not to be blind. The shield of telescopes may be made of glass and algorithms, but it is also built from resolve, the resolve to face the night with eyes open, knowing what waits within it. If humanity endures, it will not be because the cosmos spares us, but because we learn to see. The telescopes that first glimpsed Atlas are our fragile guardians, the sentinels of a species that refuses to accept silence as its fate. In their mirrors, we see not only strangers from afar, but ourselves, watching, waiting, and hoping that knowledge will be enough. The question of origin loomed like a shadow. From what distant cradle of stars had 3i, Atlas, been born? To trace its path backward through the solar system was to watch it unwind its thread across the galaxy, a traveler whose roots lay far beyond our reach. Astronomers ran simulations, rewinding its trajectory, seeking clues among the constellations. Though uncertainty blurred the details, broad hints emerged. Its velocity, its angle of approach, its very eccentricity marked it as a child of another star. Perhaps it had been cast free from a planetary system orbiting a sun not unlike our own. Perhaps it had been born in the chaotic nurseries, where stars are packed tightly, gravitational tugs casting debris outward like sparks from a forge. The great stellar associations, Orion, Perseus, Carina, all teem with such violence. Atlas may have been one of countless fragments hurled into the interstellar dark during those turbulent millennia of formation. The thought itself was staggering. Here, in our skies, was a stone that might once have orbited a planet circling another Sunday. Perhaps it had grazed the rings of a giant world or collided with a sibling asteroid before a gravitational encounter with a gas giant slingshotted it into exile. For billions of years, it drifted across gulfs of silence, carrying within it the fingerprints of its birth star, the isotopic ratios of its ices, the crystalline lattices of its minerals, the chemical flavors of a world not ours. To study it, even from afar, was to study alien history. Its dust could reveal the metallicity of a star now hidden beyond our sight. Its composition could speak of environments that no probe will ever reach. Interstellar objects are messengers of the unseen, bearing news of places we will never touch. Atlas was not only a threat, but a relic that had wandered across time to cross paths with us. Philosophers and scientists alike found themselves reflecting on the irony. For centuries, humanity has dreamed of reaching other stars. We imagine ships and sails, wormholes and warp drives. Yet, before we can leave, the stars themselves send fragments to us, emissaries of alien nurseries, arriving without invitation. The universe, in its indifference, provides samples of its own, though often wrapped in the possibility of annihilation. There is also a sobering thought in its origin. If Atlas was born of planetary formation, then it is one among countless trillions. Every system scatters debris, every birth of worlds casts stones into the dark. The galaxy is not empty, but filled with these orphans, drifting endlessly. That we have now seen 3 in as many years suggests not rarity, but abundance. The Milky Way may be a sea thick with interstellar wanderers, their silent trajectories threading through the gulfs between suns. And if they are abundant, then encounters are inevitable. Atlas is not an anomaly, but a reminder. Its alien origin is less a curiosity than a warning that the universe is porous, that no solar system is sealed, that the borders between stars are as thin as the silence of space. To gaze upon Atlas is to look upon a fragment of another sun's story, a shard of creation cast outward into the infinite. It is both relic and threat, both messenger and potential executioner. In its origin lies the vast truth of the cosmos, that worlds are fragile, stars are violent, and the debris of creation drifts forever, waiting for chance to bring it home to someone else's sky. To call 3I Atlas a relic is no exaggeration. It may be a survivor from the earliest age of a planetary system, when dust and gas circled a young star like a halo, colliding and fusing into worlds. In those primordial disks, chaos ruled. Gravity sculpted order, but it also flung fragments outward, ejecting countless bodies into the void. Atlas may be one of those outcasts, a shard from a planet that never fully formed, or from one torn apart in violent infancy. Such relics are invaluable to science. They are time capsules, preserving chemistry from eras we cannot witness. A fragment cast out billions of years ago would carry within its atoms the story of a distant star's birth. Its ices might hold isotopes formed in explosions of supernovae, locked away before our sun was even born. Its minerals could show crystalline structures shaped by pressures and temperatures unlike anything in our solar system. Every molecule within it is a sentence written in the language of alien creation. In imagining its history, astronomers paint scenes both wondrous and violent. Perhaps Atlas once circled close to a giant planet, its orbit destabilized by gravitational resonance. Perhaps it was struck by another body, fractured and cast free. Perhaps it never belonged to a planet at all, but coalesced briefly in a disk of gas, then wandered outward, too small to be claimed, too large to vanish. Whatever its path, it became an exile, drifting endlessly in the spaces between stars. This wandering speaks to a deeper truth, that planetary systems are not perfect, harmonious clocks. They are messy, violent forges, scattering debris across the galaxy. Every star is surrounded by invisible clouds of such relics, unseen wanderers waiting for chance encounters. 3I, Atlas, is one that happened to cross ours. How many more slip through unobserved, dim and distant, we cannot know. To stand on Earth and watch such a relic approach is to feel the cosmos collapse into intimacy. Here, above our skies, is material that once belonged to another world. It is as though a fragment of an alien landscape had drifted across the light years to brush against us. For scientists, the temptation is profound, to sample it, to study it, to read its chemistry like scripture. For humanity at large, the meaning is heavier, to recognize that such relics can also be weapons, carrying annihilation along with knowledge. Relics remind us that creation and destruction are inseparable. The same collisions that eject objects like Atlas also forge planets. The same forces that threaten Earth once birthed it. In its cold silence, Atlas carries both sides of this truth. It is a remnant of alien creation, but to us, it is the face of destruction. The philosophical weight is enormous. Humanity has always sought relics, fossils, ruins, scrolls, fragments of the past that give us meaning. But here is a relic not of our history, but of the universe itself. To hold it, to touch it, would be to touch the ancient alien chaos of another star's birth. And yet, we may never touch it at all, for if it collides with us, the relic will not be preserved, it will be annihilation itself. 3I. Atlas is both archive and apocalypse, both messenger and destroyer. Its very presence reminds us that to live in the cosmos is to live surrounded by relics of creation, and that sometimes those relics fall. Even as astronomers traced the path of 3I, Atlas, they confronted the limits of certainty itself. The cosmos, vast and precise in its laws, is also chaotic in its details. The smallest forces can bend destiny, and in the case of interstellar travelers, those forces multiply into fogs of unpredictability. At the heart of this uncertainty lies quantum mechanics, not in the mystical sense of particles deciding fates at random, but in the practical truth that measurement is never perfect. Every observation of Atlas, every faint smear of light upon a sensor, every plotted point against the stars carried errors. Those errors, when projected forward, blossom into vast corridors of possibility. A few pixels deviation today becomes thousands of kilometers uncertainty tomorrow. The path of a traveler is never a single line, but a cloud of potential futures. Add to this the chaos of dynamics. An object like Atlas, tumbling, perhaps outgassing faintly as hidden ices sublimate, can shift subtly under forces invisible to the eye. A jet of vapor, no larger than a plume of smoke, can, over millions of kilometers, nudge its course by thousands. Solar radiation, though weak, exerts pressure photons themselves, pushing against its surface, altering its arc. These influences, small as whispers, accumulate into differences vast as worlds. And so, predictions blur. Scientists run simulations not once, but millions of times, each variation a roll of cosmic dice. Some futures show Atlas passing harmlessly, vanishing into the dark. Others show near approaches, close enough to stir tides or burn in the atmosphere. A few rare, but never zero, show impact. Within that cloud of probability lies both comfort and terror. Comfort, because many paths end without destruction. Terror, because one does not. This is the paradox of interstellar threats. Certainty is a luxury we cannot afford. Local asteroids, bound in repeating orbits, can be tracked with confidence centuries ahead. Interstellar wanderers are strangers. They arrive suddenly, stay briefly, and depart forever. Their trajectories are not rehearsed but improvised, subject to forces we barely glimpse. By the time they are seen, their fates are already entangled with ours, and we cannot know which outcome will unfold until the final approach. Philosophically, this uncertainty is its own kind of wound. Humanity longs for prediction, for mastery, for the comfort of knowing. But Atlas reminds us that the universe is not obliged to be predictable. It is precise in its laws, yet chaotic in its outcomes. It gives us equations, then hides the variables. It offers us probability instead of fate. For some, this uncertainty feels cruel. To know of a possible annihilation and yet not know its likelihood is to live under a suspended sword. For others, it is strangely merciful. The same uncertainty that allows doom also allows escape. Until the final moment, the outcome remains unwritten. And so, astronomers speak cautiously, couching their words in ranges, probabilities, error bars. They do not declare apocalypse, nor do they promise safety. They stand in the in-between, acknowledging that chaos has the final word. The rest of humanity, less patient with ambiguity, feels the tremor of fear that comes with not knowing. This is the true lesson of Atlas's uncertainty, that knowledge has limits, and beyond those limits lies humility. The universe may be governed by laws, but to us, within our narrow windows of measurement, it remains partly unknowable. The fate of Earth before an interstellar traveler is not written until it happens, and in that uncertainty, we find both our greatest terror and our only hope. Beyond the equations and the simulations lies a different frontier, the human one. What happens when entire societies awaken to the possibility that 3I, Atlas, an interstellar wanderer, may be on course for Earth? How does civilization react to the whisper of extinction hanging not in centuries, but in years or months. History offers fragments of an answer. When comets blazed in the ancient sky, empires trembled. Records from China, Babylon, and Europe describe panic, rituals, prophecies of doom. Even in modern times, when Halley's Comet returned in 1910, fear spread that its tail contained cyanide gas capable of poisoning the atmosphere. The power of the sky to stir dread has always outstripped reason. What then, when science itself confirms the possibility of impact? The first stage would be disbelief. Governments, cautious of panic, would soften the language. Agencies would speak of probabilities, of monitoring, of low-risk scenarios, yet rumors would spread faster than official words. Media, hungry for attention, would amplify every hint of danger. Conspiracy theorists would claim cover-ups, prophets would declare fulfillment of ancient visions, and ordinary people would feel the weight of uncertainty pressing into their daily lives. Next would come fracture. Some nations would prepare in silence, diverting resources to bunkers, shelters, or evacuation plans. Others would deny the threat, unwilling to disrupt economies or admit helplessness. Mistrust between nations would deepen as satellites tracked the object's approach and each wondered what the other knew. Survival, once a collective challenge, would dissolve into suspicion and division. For individuals, the reactions would vary as widely as humanity itself. Some would cling to faith, seeing in Atlas a divine judgment or a cosmic test. Others would embrace fatalism, living recklessly in the shadow of possible doom. A few, driven by resilience, would work tirelessly to plan, to warn, to build what defenses or refuges might be possible. And many would simply continue, clinging to the ordinariness of life as the extraordinary drew near. Psychologists call this anticipatory grief, the mourning of a future that may never arrive. The knowledge of possible annihilation would ripple through families, communities, cultures. Art would reflect it, music would echo it, conversations would circle it endlessly. Every sunrise and sunset would carry the unspoken question, how many are left? The paradox is cruel, for the more closely astronomers study Atlas, the narrower the range of outcomes becomes, and yet until the final weeks, uncertainty would remain. Civilization would live suspended between apocalypse and reprieve, unable to prepare fully for either. To some, this uncertainty would be unbearable. To others, it would be a strange kind of mercy, allowing hope to survive until the last moment. What would humanity choose to do with its possible final months? Some imagine chaos, riots, collapses, wars ignited by desperation. Others imagine unity, nations setting aside differences to face a shared fate. Reality would likely hold both pockets of violence, pockets of cooperation, the full spectrum of human behavior condensed into a brief, unbearable time. In contemplating 3I, Atlas, we are forced to imagine not only the physics of collision, but the sociology of fear. The cosmos does not only test our survival, it tests our spirit. And the question becomes as much about what we would do before impact as about the impact itself. Would humanity fracture under the weight of dread, or would it discover a final, fleeting unity? The fear of falling stars is older than science itself. Long before telescopes, long before orbits were understood, humanity looked upward and saw omens streaking across the night. Comets, meteors, fireballs, they were not understood as natural phenomena, but as messages from the gods, harbingers of death, or signs of cosmic displeasure. In the shadow of 3I, Atlas, those ancient myths resurface, carrying echoes of how deeply humanity has always feared the heavens. In Mesopotamia, clay tablets recorded comets as warnings of kings' deaths, the rise of enemies, the collapse of empires. Babylonian astrologers traced fiery visitors as symbols of divine judgment, weaving them into the fate of nations. In China, imperial astronomers feared comets as omens of dynastic change. Records describe rulers ordering sacrifices, ceremonies, even purges to appease the heavens when new stars flared in the sky. In medieval Europe, comets were thought to carry plague and war. Chroniclers of the Black Death wrote of burning stars that preceded waves of illness, as if the sky itself had poisoned the earth. In 1066, the Bayeux Tapestry immortalized Halley's Comet as a sign of doom for King Harold before the Battle of Hastings. To see a bright streak in the heavens was to see history rewritten by fire. These myths carried not only fear but awe. Falling stars were bridges between worlds, sudden tears in the fabric of the sky. Some cultures saw them as souls ascending, others as spirits descending. The heavens were not silent. They spoke through light and fire. Even today, the language remains. We still say shooting stars, as if each were an arrow of destiny loosed from the cosmos. The myths matter because they reveal something deeper. Humanity has always sensed its fragility before the heavens. Long before the physics of impacts were known, people felt the truth in their bones that what falls from the sky can change everything. The terror was not misplaced. Chicxulub proved the fear correct. Science has replaced superstition, but the awe remains, rooted in survival itself. And now, with 3I, Atlas, myth and science converge. What once was prophecy is now probability. What once was omen is now orbit. The fear that once belonged to kings and priests now belongs to astronomers and physicists, yet the essence is the same. The recognition that the heavens are not still, and that sometimes they fall. In a way, the myths were our first planetary defense. They kept eyes turned upward, reminded civilizations that the cosmos was alive, unpredictable, and dangerous. They wove cosmic anxiety into ritual, culture, and law, and though they lacked equations, they were not entirely wrong. They sensed what we now know, that the universe is not benign, and that falling stars can erase worlds. 3I. Atlas would be the fulfillment of every ancient fear, the omen not of kings' deaths, but of humanity's, the falling star, not as symbol, but as fact. And in its approach, we would hear again the whispers of our ancestors who trembled beneath comets, who wove myths to explain the streaks of fire, who sensed long before science that the sky above is both shelter and threat. If the physics of 3I, Atlas speaks of annihilation, speculation stretches further still into the strange refuge of theory. For when confronted with the possibility of extinction, the human mind turns not only to defense, but to escape. And here, the most radical ideas emerge. The multiverse, alternate realities, parallel timelines where the impact never occurs. Physicists do not invoke these ideas for comfort, but from mathematics. The inflationary model of the early universe, in which space itself expanded faster than light, suggests that countless bubble universes may have formed, each with its own laws and histories. Quantum mechanics, with its branching probabilities, whispers of worlds where every possibility is realized. In some versions, Atlas exists but passes harmlessly. In others, it never formed at all. And in still others, it collides with Earth, ending humanity in silence. These are not certainties, but speculations grounded in equations. The multiverse cannot be observed directly, yet its fingerprints appear in the strange uniformity of cosmic background radiation, in the riddles of quantum entanglement, in the deep puzzles of fine-tuned constants. It is as though the universe itself hints at realities beyond our own, veiled but possible. To imagine Atlas in this context is to expand fear into philosophy. Perhaps in some other world, another humanity looks upward and sees the same traveler, but watches it pass by, harmless and beautiful. Perhaps in another, the collision has already ended their story, and no one remains to tell it. Perhaps in yet another, there was no Earth at all, no fragile biosphere, no eyes to look upward in fear. The comfort, if it can be called that, lies in perspective. The multiverse reminds us that destruction here does not negate existence everywhere. Our annihilation would not erase the cosmos, only our thread of it. Life, in other branches, may continue or even thrive. The tragedy is that we are bound to this one, unable to slip sideways into another. The physics that suggests escape also denies it. And yet, speculation has its power. To imagine alternate realities is to remind ourselves that existence itself is improbable. That among countless possible universes, this one allows stars, planets, life, and us. That the fragility we feel before Atlas is the same fragility that made us possible at all. In some sense, every day of survival is already a miracle, purchased from probability. For those who fear, the multiverse offers a strange solace. Somewhere, another Earth survives. For those who reflect, it offers humility, that survival here is not guaranteed, and that our story is but one among countless untold. Atlas, in this light, is not only a threat, but a reminder that to live is to exist precariously, balanced on the edge of chance. If the collision came, and if humanity perished, the multiverse would not mourn. In some other branch, another version of us would endure. In yet another, we never were. The cosmos is vast enough to hold every possibility. Our fear, then, is not of the universe ending, but of our small, singular world closing its book. If 3I, Atlas, were to strike, and if humanity endured in fragments, the question would not only be of survival, but of rebuilding. The Earth, after such an event, would be transformed, landscapes scoured, climates shattered, ecosystems collapsed. Could humanity, or any intelligent remnant, terraform its own ashes? Terraforming has long been a dream directed outward. We imagine reshaping Mars, thickening its air, warming its frozen plains into seas. We imagine domes upon the moon, or cities buried beneath ice on Europa. But in the wake of an interstellar collision, the first candidate for terraforming would not be another world, it would be Earth itself. The atmosphere, choked with dust, would require clearing. Methods are imagined, orbiting mirrors to focus sunlight, engineered microbes to bind and sink, aerosols, vast networks of filters and pumps. Oceans, poisoned by acid rains and debris, might need neutralization, seeding with compounds to restore balance. Croplands, buried beneath ash, could be revived by bioengineered plants, able to photosynthesize in dim light. The planet, though wounded, could become a project of restoration. Yet, such visions demand more than technology. They demand survival of knowledge. Libraries, servers, laboratories, these must endure the initial chaos. Without them, the survivors would face centuries of darkness before rediscovering what was lost. The ability to terraform Earth would rest upon whether fragments of civilization could preserve science through famine and collapse. It is not only soil and air that would need rebuilding, but memory itself. Even if restoration proved possible, the psychological transformation would be profound. Humanity, once master of a stable climate, would become a gardener of a broken one. Every sunrise would remind survivors that their world had ended once, and that its second life was fragile, artificial, and conditional. The relationship between civilization and nature would be rewritten, no longer taking Earth's stability for granted, but shaping it deliberately, painfully, day by day. There is precedent, faint but instructive. After volcanic winters, societies have endured years of famine, adapting with migration, ingenuity, and stubborn persistence. After ice ages, life returned, reshaping itself into new ecologies. The Earth is resilient, but resilience is not the same as permanence. The survivors of Atlas would inherit a planet capable of recovery, but not without scars. Forests would regrow, but different ones. Oceans would teem again, but with new dominants. Humanity, if present, would live among landscapes both familiar and alien, a world reborn yet haunted. Terraforming Earth, after Atlas, is less science fiction than necessity. It is the recognition that survival is not the end of the story, but the beginning of a harder one. To endure would mean to accept stewardship over a wounded planet, to reimagine civilization not as conqueror of nature, but as caretaker of its fragile recovery. And yet, there is an irony here. Humanity dreams of terraforming Mars because Earth feels eternal. But Atlas reminds us that even Earth can die, that terraforming may one day be less a dream of conquest than an act of mourning. The question is not whether it can be done, but whether survivors, scattered and starved, could summon the will to attempt it. If Atlas collides, the legacy of humanity will not rest on preventing disaster, but on answering this question: can a species rebuild its own cradle after it has been broken? When civilizations face annihilation, they often turn their gaze outward, beyond the moment, beyond even survival, toward the question of legacy. If 3I, Atlas, were destined to collide with Earth, humanity's instinct would not only be to endure, but to be remembered. What message, then, could we send into eternity before the final dawn? The idea is not new. Already, fragments of our story sail among the stars. The Voyager spacecraft carry golden records etched with sounds of Earth greetings in dozens of languages, music from Bach to Chuck Berry, images of forests, oceans, and human faces. The Pioneer plaques, simpler still, display diagrams of our place in the cosmos, crude sketches of humanity's form. These were not defenses, but whispers, a declaration that we existed, that our story mattered enough to cast into the void. In the shadow of Atlas, such efforts would take on new urgency. Perhaps humanity would rush to build more messages, coded into beams of radio light hurled toward nearby stars. Perhaps great vaults would be buried on the Moon or Mars, carved into stone or etched into metals designed to endure for millions of years. Perhaps even genetic blueprints, seeds, DNA, or digital archives would be preserved in the hope that another civilization might one day resurrect what we were. The content of those messages would be a question as heavy as the impact itself. What do we say when speaking for an entire species? Do we offer warnings, describing the fate that befell us, hoping others might avoid it? Do we offer beauty, art, music, philosophy as a testament to what life can create even in the shadow of extinction? Do we offer raw data maps, equations, a manual of survival, as if preparing strangers to inherit what we could not preserve? Some would argue for honesty, to confess our flaws, our wars, our failures. Others for celebration, to show only the best of what humanity achieved. Perhaps the truest message would be both that we were flawed yet striving, fragile yet luminous, a species that burned brightly, though briefly. And there is the haunting possibility that no one will ever read these messages. The galaxy is vast, and silence stretches between stars. Perhaps the golden records will drift forever, untouched. Perhaps lunar archives will lie buried in dust long after Earth is unrecognizable. Perhaps our messages will be nothing more than monuments to ourselves, unread but still meaningful, because they affirm that we tried. In the end, the act of sending the message may matter more than whether it is received. To etch our existence into the cosmos is to resist erasure, to declare, we were here, and we knew, and we hoped. If 3I, Atlas, were to end us, then the messages we leave behind would be our final act of defiance against oblivion. They would be the echo of our voices in a universe that does not listen, the trace of our fire in a cosmos that does not care. And yet, in that silence, the act itself becomes profound. For to send a message to eternity is not only to ask to be remembered, but to remember ourselves that even on the edge of annihilation, humanity chose to speak. There is a silence at the heart of physics. It is the silence of laws that govern without pity, without mercy, without intention. When we imagine 3I, Atlas colliding with Earth, we may be tempted to ask why. Why here? Why now? Why us? But the universe offers no answer. It does not choose. It only moves. The silence of physics is not indifference in the human sense, but absence of concern. Gravity does not pause to ask whether a collision will extinguish civilizations. Thermodynamics does not soften because famine follows winter. Quantum mechanics does not bend to fear. The laws are impartial, relentless, and complete. They explain everything, yet console nothing. For humanity, this silence is the deepest wound. We search for meaning in catastrophe, yet find only equations. The Chicxulub impact was not sent to end the dinosaurs. Tunguska was not aimed at Siberia. If Atlas strikes Earth, it will not be judgment, nor fate, nor prophecy fulfilled. It will simply be the consequence of trajectories crossing in space-time. Physics writes no moral into the story. And yet, in this silence lies both terror and beauty. Terror, because it strips us of illusions. The cosmos does not conspire for or against us. We are fragile, temporary, at the mercy of forces unimaginably larger than ourselves. But beauty too, because the same laws that annihilate also create. The gravity that hurls asteroids also shapes stars. The thermodynamics that freezes worlds also fuels life. The silence is not cruelty, it is symmetry. Still, the indifference can feel unbearable. To imagine Earth erased by an object from another star is to confront how little our achievements matter to the universe at large. Our empires, our art, our languages, our dreams, none are protected. The silence of physics will not preserve them. It will not grieve their loss. But perhaps that silence also grants freedom. If the cosmos has no concern for us, then meaning is ours to create. Our lives, our civilizations, our stories become precious not because the universe guarantees them, but because it does not. We exist in defiance of silence, carving voices into a reality that would otherwise remain mute. Atlas, in this sense, is not an enemy, but a mirror. It reflects the truth of our condition, that survival is never promised, that existence is precarious, that meaning must be made, not found. To fear its collision is to fear physics itself, but to understand it is to see that our brief moment beneath the stars is all the more miraculous because it is not owed. The silence of physics endures. It will outlast us, outlast Earth, outlast even the stars. But in this moment, while we live, we have the power to speak into that silence, to create, to love, to wonder, to resist. And if one day Atlas should erase us, it will not erase the fact that for a while we spoke against the quiet, and the quiet was not absolute. In contemplating 3I, Atlas, humanity is forced to confront the rarity of its own existence. Life, as far as we know, is a fragile miracle. Across billions of stars, we have yet to find another Earth, another species staring upward, asking the same questions we do. The collision of an interstellar body with our planet would be more than a natural disaster. It would be the silencing of one of the universe's rare voices. The miracle lies in improbability. The Earth orbits at the right distance from the Sun, within the narrow band where water can flow. Our atmosphere is thick enough to shield us from radiation, yet thin enough to breathe. Our magnetic field guards us from cosmic storms. Even our moon, born of an ancient collision, stabilizes our tilt, softening the chaos of seasons. Life flourished not because the universe is kind, but because conditions aligned by chance. For billions of years, those conditions endured, and from that endurance came forests, oceans, animals, and minds capable of wonder. To imagine Atlas striking Earth is to imagine that miracle undone, a planet still spinning, still orbiting, still bathed in sunlight, yet stripped of its living veil, an ocean without whales, a sky without birds, continents without people, a world that remains beautiful but silent, a stage with no actors left upon it. And yet, to recognize fragility is also to recognize value. If life is rare, then every day it continues is extraordinary. The possibility of annihilation is not only a threat, but a reminder of what we possess. The laughter of children, the rhythm of tides, the glow of cities at night. These things are not guaranteed. They exist only because chance has spared us so far. Philosophers call this the paradox of existence. We are at once insignificant, a speck of dust in an infinite cosmos, and yet immeasurably precious, for we may be among the few specks that can think, feel, and dream. The same physics that makes collisions inevitable also makes consciousness possible. The same universe that hurls Atlas at us also gave us the ability to name it. In this light, the fragility of life is not weakness, but wonder. That we exist at all, that we gaze upward and measure trajectories, that we fear and hope these are miracles disguised as inevitabilities. If Atlas were to strike, it would remind us not of meaninglessness, but of how rare and luminous our brief moment has been. The fragile miracle of life is not measured in permanence, but in presence. We are here, now, speaking into the silence. That may be enough. And perhaps, if messages survive in spacecraft, or if life endures in hidden refuges, the miracle will not end but transform. For fragility does not erase value, it amplifies it. To stand beneath the stars and contemplate annihilation is to realize that our existence is a candle lit against the dark, small, brief, but real, and for as long as it burns, it is the rarest light in all the universe. And at last, the story turns toward its closing image, the last dawn. If 3I, Atlas, were truly to strike Earth, there would be a morning unlike any other. A pale light would creep across the horizon, but beneath it, the world would hold its breath. The sky would seem unchanged, the seas would still murmur upon their shores, the cities would wake as they had countless times before. Yet overhead, invisible to most, the traveler would be descending, a silent executioner written into the geometry of space-time. In those final hours, the ordinary would coexist with the extraordinary. Children would laugh, markets would bustle, lovers would whisper, and all of it would unfold under the shadow of inevitability. Some would face it with denial, others with prayer, still others with a strange serenity. For when the end is certain, the spectrum of human response reveals itself: fear, defiance, grief, and acceptance. Then the sky would change. A streak brighter than the sun would appear, a second dawn splitting the heavens. Shadows would stretch, birds would scatter, and hearts would falter. The fire would grow, consuming clouds, horizon, and air itself. And before thought could catch breath, the world would be unmade. Fire, shock, ocean, dust, the sequence unstoppable, the silence of physics unfolding in its final verse. But even in imagining this last dawn, one feels not only terror, but awe. For what is an impact but proof that we lived in a universe alive with motion, a universe that gave us stars to study, questions to ask, and time enough to wonder? The fragility of our story does not erase its beauty, it deepens it. And so, the narration slows, words soften, the cadence lengthens, as though the very voice of the cosmos wishes to comfort in its indifference. Yes, annihilation is possible. Yes, our survival is precarious. But in the immeasurable gulf of space and time, we existed. We thought, we dreamed, we loved, and we left traces in the dark. The last dawn is not only an ending, it is also a reminder of what it meant to live beneath the stars. If Atlas were to strike, it would erase us, but it could not erase the fact that we were here, that the fragile miracle of life once burned bright upon a small blue world. And if it passes us by, vanishing once more into the silence between suns, then we are granted more time, time to cherish, time to prepare, time to remember that every dawn is borrowed light. So the story closes, as all stories must, not with thunder, but with reflection. The sky grows dim, the words fall quiet, and the voice withdraws, leaving behind only a whisper. The universe is vast, the dangers are real, but so too is the wonder. And now, as the candle of this tale flickers low, let the listener rest. Let the fear dissolve into calm. Let the night cradle what remains, for tomorrow will come, whether in light or in silence. And so, the narrative fades, its fire softening into embers, the great collision imagined, the devastation traced, the silence of physics acknowledged, all now recede into distance. What lingers is not fear, but quiet. For even in contemplating annihilation, one is reminded of the tender strangeness of being here at all. The voice slows, like breath, at the end of a long night. Sentences lengthen, pausing between thoughts, leaving space for stillness. The imagery softens, no longer burning skies or shattered continents, but oceans at dusk, stars reflected upon calm waters, forests breathing quietly beneath a silver moon. The violence imagined dissolves into the serenity of what is, here and now. The listener is invited to rest in that serenity, to feel the weight of survival not as dread, but as gratitude. Every day, every dawn is already a gift purchased from the silence of space. The threat of objects like Atlas only deepens the truth that life is rare, fragile, and worth cherishing. And so, the tale closes not with the sound of impact, but with the hush of reassurance. The universe may be vast, indifferent, alive, with forces beyond control, yet within it, for this moment, we are safe. We breathe, we dream, we endure. The stars wheel overhead as they always have, and the earth turns steadily beneath our feet. Rest, then, with that knowledge. Let the fears of collision and extinction fall away, leaving only the calm rhythm of existence. Sleep beneath the shelter of the night sky, knowing that the cosmos is both storm and sanctuary. Tomorrow, the world will still be here, and so will you. Sweet dreams.